So curvilinear motion slash parametric form, all, kind of all the same stuff. So it's basically using derivatives in order to find how things are moving, what speed they are, whatnot. So you may already know this from physics class, but velocity is actually just the derivative of the function of displacement. So if you have, a function that says where something is at a certain time, the derivative of that will be its velocity. And the derivative of that, so the second derivative, will be its acceleration. So, for example, let's take a look at this question we have right here. So we're given how a thing moves in both the x and y direction, right? We have two separate equations. We have an equation for how this object moves in the x coordinate and also in the y coordinate, or the y-axis. That's a better way to put it. So, we have these two equations. And so they want us to find the velocity at the angle when t is equal to 2. So these equations, of course, like I said, they give us the position of the object, the displacement, at a certain point in time, at t. So if we have these equations for displacement, then we need to find the derivatives of them, because the derivative of displacement is velocity. So we have x equals 3t squared. We find the derivative of that, 6t. That's equal to the velocity of x. Y is equal to 1 minus t squared. We find the derivative of that, negative 2t. And that is the velocity for the y direction. Now we have these general equations, right? These will give you the velocity in the x and y direction at any time. They give us a specific time to analyze, t equals 2. So you're just going to plug t equals 2 into the derivatives. So 6 times 2 is 12. Negative 2 times 2 is negative 4. So now we want to find, so we have the velocities in the x direction and the y direction at the specific time. We want to find the overall velocity. And to do that, you need to know this equation. Hopefully you do remember this from physics. If not, then I'd say you should probably just memorize it because it's pretty valuable. So it's a square root of velocity x squared plus velocity y squared. So that's what we have right here. Velocity is equal to 12 squared plus negative 4 squared. Of course, negative 4 squared becomes a positive, so it doesn't really matter if you write it in as negative, but just be consistent. And we get an answer, it's about 12.65. So then it also asks us for the angle. So for that, we're going to do this equation right here. Inverse tangent of vertical velocity over horizontal velocity. Again, I'm not going to describe like how this works. This is trigonometry. Hopefully you already know it. If you don't, then review your trigonometry. Basically, you're just going to do an inverse tangent. You're going to take your vertical velocity, which is negative 4, put it over your horizontal velocity, which is negative 12, and we get about negative 18.43 because the horizontal velocity is positive while the vertical velocity is negative. We can say that the object is going like this way, something like that, and this would be the angle that we found because horizontally it's positive, right? Right direction is positive, but vertically it's negative, so it'll be something like that. So this is probably the most basic kind of curvilinear motion question you would get. Next examples I'll show are a little bit more complicated, but still pretty straightforward. Okay, so here we have a question that's a touch more complicated. So in the previous one, we had the y and x positions given to us by a function of time, which meant that if you wanted to find the velocity, all you have to do is find the basic derivative of that because velocity is, of course, the derivative of the function of displacement. In this case, we have something a bit different. So the object that we're looking at moves along this path, right? So this is a path that it's on. So if, say x is 2, then the y value will be 1.33. If you put x here 2, that's what you'll get. So, and this isn't a function of time, right? And then they also give us, however, they give us the x velocity. So at all times, the horizontal velocity is 6.00 to be more specific. That's for significant figures. Not too important, but try to keep track of significant figures if you can. So we have velocity of x, which is of course the derivative of x with respect to t, and they also tell us they want us to find the velocity at this specific point. So when the object is specifically at 1.333, that's where it wants us to find the velocity. So we already have the x component velocity, we have to find the y component. So to do that, we need to find the derivative of y with respect to t. However, here's the thing. The equation that we have for y isn't in respect to t, it's in respect to x. So we can't just find the derivative of this and be done. That's not good enough. We have to, we have to do a bit of a two-step process. So this is what it is, right? So we have the derivative of y with respect to x times the derivative of x with respect to t. So why this works the way it does, well, okay. So we're trying to find the derivative of y with respect to t. If you look at this, like if we just pop this out here, derivative of y with respect to x times derivative of x with respect to t. If you multiply these together, you'll realize something. These two things cancel out. So you end up with derivative of y with respect to t, right? If these two cancel out, these are what you have left. It's perfect. This is exactly what we need. So if we're looking for the derivative of y with respect to t, but all we have is y with respect to x and x with respect to t, then we can combine them together using this. So that's what we do. We have the derivative of y with respect to x, which is pretty simple. It's just 2 over 3 times x, right? Just basic power rule. And then we multiply it by the derivative of x over t, or sorry, the derivative of x with respect to t, which they give to us at 6. And so we have 4.00x. That is the y component of our velocity. So now, of course, the y component of our velocity is relative to our x value. They give us an x value of 2, so now we take that x value, plug it into our derivative, and that is our vertical velocity at that specific moment. And so now we have everything we need, right? We have the horizontal velocity, we have the vertical velocity, we just found it. So now we just do the velocity equation from before to find the total velocity, which is 10. And then we also find the angle, which is about 53.1 degrees. And because, again, this is just a trigonometry thing, because both the values are positive, we know that it's moving something like that, like in that direction. And then this would be our angle. And yeah, that's a bit more complicated example of curvilinear motion. If you get a curvilinear motion question, or just a word question in general, odds are it's going to look something like this. They'll give you a derivative like this for free in the question, and then they want you to find something else using that derivative in a two-part process like this. So in this case, we're trying to find the derivative of y with respect to t. So you find the derivative of y with respect to x, and then you find the derivative of x with respect to t. And if you're not sure how to find it, right, you're looking at the question and you don't know what to do, well, first of all, identify what you're trying to find. So we're trying to find the derivative of y with respect to t. Okay, identify it, write it out, and then look at what you have. So in this case, we have the derivative of x with respect to t. That's what they gave us. Those are the numbers, that's the info that they gave us in the question. So write that out and then sort of look at it and be like, okay, how can I use this, the derivative of x with respect to t, to find the derivative of y with respect to t? And we also, of course, are given this function, we're given y with respect to x. And so with, a bit of problem solving, you can figure out this, right? You can figure out that if you find the derivative of y with respect to x, you can use that along with the derivative of x with respect to t to find the derivative of y with respect to t, which is what we're looking for. So these questions aren't too complicated, at least what we've been given so far. So hopefully Now that you understand this, the next time you look at a question like this, you'll be able to reason out what you're supposed to do.